If you lived in the heart of the Milky Way, night would never be dark. The stars would be so close that the nearest one could fit inside our own Oort Cloud. Some would streak across the sky at 15,000 miles per second. That's almost 8% of the speed of light. These stars orbit an invisible black hole. It's both scary and fascinating at the same time. That's the scene waiting for us if we traded our quiet neighborhood in the Orion Arm for a window with a direct view of the galactic center. Long before we knew what a galaxy was, looking at the sky hypnotized us. Ancient observers told stories with constellations and marked time by rising stars. Admiration gave birth to astronomy, one of humanity's earliest sciences. Maybe the very first science we ever created. As full as Earth's night sky seems with thousands of points shining, it's only a timid sketch of what exists. Just imagine what if, instead of living on the edges, we were at the center of this stellar whirlpool called the Milky Way. To answer that, it helps to understand the house we're in. Our galaxy is about 100,000 light-years across. It's a disk roughly 1,000 light-years thick and more than 13 billion years old. Inside that space, estimates range from 100 to 400 billion stars. But what we found about these stars changes everything we thought we knew about galactic neighborhoods. And it starts with color. The Milky Way's disk tends to look bluish because it hosts many young hot stars, especially types O and B. The central bulge, that thicker bump in the middle, leans yellow and reddish. It's dominated by older stars, red giants, and supergiants. There, star formation is far less active than in the arms. This changes the color, the energy, and of course, the sky scenery for anyone living nearby. Most stellar mass sits within a region about 80,000 light-years in diameter. Beyond that, density drops sharply. Now, if we multiply stars, we multiply worlds. The number of exoplanets in the Milky Way is probably comparable to, or even greater than, the number of stars. And here's a detail that excites anyone dreaming of life beyond Earth. Small planets, roughly Earth's size, seem to be more common than gas giants. About 1 in 5 stars in the galaxy is similar to the Sun. Around 1 in 6 of those Sun-like stars hosts at least one Earth-sized planet. We're talking about more than 17 billion Earth-scale worlds. So, where does our cosmic family fit into this? The solar system lives about 26,000 light-years from the galactic center. We're in a smaller structure called the Orion Arm, a secondary spur between two larger arms. It's a quiet neighborhood by galactic standards. On perfect nights with no light pollution, we can spot a few thousand stars with the naked eye, around 6,000 on average. In our immediate surroundings, the sun reigns pretty much alone within 1 cubic parsec. There's no companion star. It's broad, quiet space. Now, take an imaginary trip toward the center. With each parsec you move into the bulge, the stellar soup gets thicker. Once there, estimates point to something like 10 million stars crammed into each cubic parsec. That's 50 million times denser than here. In practice, average separations between stars drop to something like 860 astronomical units. The closest star to the Sun today, Proxima Centauri, is about 4.3 light-years away. In the center, average distances fall to just 0.4 light-years between neighbors. But what would the sky actually look like from there? The answer is stranger than you might expect. The sky seen from a planet in that region would be a permanent spectacle. Instead of a dark dome sprinkled with dots, you'd see a glowing fabric marked by a crowd of stars, many of them red giants and supergiants peppered with intense rarities like Wolf-Rayet stars. The visual density could be up to 1 million times greater than what we're used to. In one patch of sky, you could pick out a small cluster of stars tracing tight orbits at absurd speeds. That's the Sagittarius A star cluster dancing around the supermassive black hole. The closest ones break speed records, reaching about 15,000 miles per second. It's like watching gravity in its extreme form, sculpting paths at the limit. Even with older stars dominating the bulge, the galactic center is not synonymous with calm. Astronomers have identified more than 100 massive O and B type stars there, along with Wolf-Rayet stars. These are huge, scorching, short-lived objects. They're born in groups known as OB associations. Because they live fast and die young, they die not far from where they were born. They pour out brutal amounts of ultraviolet radiation, enough energy to ionize the surrounding gas and create glowing bubbles in interstellar space. Wolf-Rayet stars have burned through much of their fuel and are shedding mass at extremely high rates. But the Milky Way isn't only disk and bulge. If you climb above the galactic plane and look toward the halo, you'll find globular clusters. Picture compact spheres with gravity so tightly bound they can survive billions of years without falling apart. They're much denser than open clusters, gathering populations from tens of thousands to millions of stars. Old reddish stars dominate there. In the cores, distances between stars shrink to roughly a third of a light year. That's 13 times closer than our current neighborhood. And what does all this proximity mean for planets? Short answer, trouble. In the dense cores of clusters, gravitational perturbations are constant. Stars pass close enough to rattle each other's orbits. Under those conditions, planetary systems become unstable. A world orbiting its star at 1 astronomical unit in the core of a cluster like 47 Tucanae would probably survive for only 100 million years. Then it would be ejected, or have its orbit warped beyond what's sustainable. But there's good news too. On the outskirts of globular clusters, the tide is calmer. Forming and keeping planets becomes more feasible. We've already found proof. The globular cluster Messier 4 hosts a planetary system orbiting a pair of stars about 12,400 light-years from Earth. One of those worlds earned a nickname, Methuselah. It's an exoplanet estimated to be 12.7 billion years old. As far as we know, it's the oldest planet ever identified, a world that began its story when the galaxy was still a teenager. So what would it be like to look up from the center of the Milky Way? You'd see a luminous, almost twilight-like dome studded with red giants and cut by ionized nebulae. In one spot, stars would be slingshotting around a gravity well that not even light escapes. But beauty doesn't mean tranquility. A neighborhood with so many nearby stars would raise the odds that extreme events would interfere with the stability of worlds. Supernova explosions, intense radiation, orbital disturbances. The chances of life persisting for millions of years would drop. In a way, we've inherited a privileged position. Not too tumultuous, not too isolated. With windows to observe and time to think. Our neighborhood, with its almost empty cubic parsec, might seem boring. But it was in this relative quiet that life had time to learn to look up. The sky we see isn't the sky, but a sky. One perspective among many inside a 100,000 light-year-wide home. At another address, nights would be brighter, danger closer, and gravity's dance more frantic. Here, darkness is the backdrop for 6,000 points and our privilege to see far.